The code could be of two types mainly, iterative or recursive. So in case of iterative, we calculate the time complexity by calculating the number of operations. By calculating the number of operations or number of loops that will run or number of times the loops will run. So in iterative, we calculate time complexity by calculating the number of times loops will run or how many loops we have in our code, or a particular loop will run how many times. And recursive, we will see after this. And one thing is, if there is no iterative or recursive function or a code in our program, that means it is of constant time complexity. That means it will take constant time complexity. Now, let's try to see with a small example. Let's try to find time complexity for this particular problem. So, we will try to find the big O notation. Like, what will be the time complexity in terms of big O notation? Because this represents worst case time complexity. And one more thing is that, as we have discussed before, that we ignore these significant terms. So when we have this, we simply write O of n square. So in this, we will only try to see the number of times a loop is getting executed, and we won't be very much bothered about that what is the number of operations that is getting executed in one loop, one iteration. So what happens is, many times we have something that we can just see directly, and we can say that, okay, as we know that this is going to run n number of times, but this depends on the value of I. So whenever we have such things which is not very obvious, we try to calculate it using various values. So let's say we have n, we want to calculate it for n. So what happens is, a loop gets executed. Obviously this gets executed from I is equal to 0 to n, and similarly this will get executed. So let's see how it goes. So when I is equal to 0, this particular loop gets executed one number of times. For I is equal to 1, this gets executed two number of times. Let's say it is equal to 1. For I is equal to 3, it gets executed three number of times. So what happens is, let's say we have n is equal to 3 only, n equal to 3. So for n equal to 3, if we have to calculate that how many times this particular loop has got executed, what do? We add this, because when, let's say we have n is equal to 3, so when I was 0, it got executed one number of times. When it was 1, it got executed two number of times. Similarly, when I was equal to 2, it gets executed three number of times, and obviously it will run only, this particular thing will run only three number of times. So what is the total number of times this loop has run? It is 1 plus 2 plus 3, which is 6. So similarly, when we have I is equal to n, how to find the total number of times this particular loop has got executed? It is 1 plus 2 plus 3, and it goes until n. So we know this is the sum of n natural numbers, which is n into n plus 1 by 2, plus this will be the time complexity for this particular loop, and this will get executed n number of times. So this will be this. So it is this. So this will be the time complexity. We can also write this as O of n square, since we are ignoring the constants and the less significant terms. So this is how we calculate the time complexity in this case. Now let's take one more example. Okay, now let's try to find out the time complexity of this particular loop. So we have to see that how many times that loop gets executed. So try to observe a behavior that in this the I is getting incremented two times in every loop. So what happens when it is getting executed for the first time? We have I is equal to 2 here. I is equal to 1 here, since it is starting with 1. So in the next iteration, I is equal to 2. So again, I is equal to 4. I is equal to 8. So you see, as iteration increases, it is getting multiplied by 2. Now we have to find out that for any n value, how many times this particular loop will get executed. So as we can see, you can see there's a pattern here. So when I is equal to 1, it is 2 to the power 0. It is 2 to the power 1. It is this. 3. This loop to end, this situation should be false. So what do we mean by that this situation should be false? So we need that 2 to the power k should be greater than n. And what does that mean? So this k is the number of times loop gets executed. So once we get this k, we say that this is the time complexity. And in this case, if we try to find, so we put log 2 at both the ends, log 2 2 to the power k, log 2 2 to the power k, and log 2n. This becomes k. So we see that this particular program runs log 2n times. So this is the time complexity. So we see that this will be the time complexity. Now we have another code and we'll try to find out the time complexity of this. So as you can see that we clearly know that this is going to run n number of times. And this we know from the previous thing that it will take iterations. Now, okay, what happens in case of loop is we always try to find out that what is the loop that is at the lowest level. What is the number of times this lowest level loop will get executed, because this will be getting executed maximum number of times, or this will be taking maximum amount of time. Now we want to find out that what is the number of times this will get executed. Let's try to again unfold it. So when we have I equal to 1, this j will execute one number of times and k will execute 100 number of times. So when I is equal to 2, j will execute 2 number of times and this k will execute 200 number of times. For I equal to 3 and k will execute 300 number of times. Similarly, if let's say we have n is equal to 3, for calculating that when n is equal to 3, how many times this is getting executed, we will add all these 300 plus 200 plus 300. So similarly, when we have to do it for I is equal to n, we add this 100 plus 200 plus 300 till n into 100. Taking 100 in common, we get 1 plus 2 plus 3 till n, and we know that sum of this is 100 into n square plus n by 2, and this is equivalent to O of n square. So this will have time complexity of O of n square. Now let's take another example. Now let's try to find out time complexity for this. Now again, we know that this will execute n number of times. Now we have to find out for this and for this. So what happens is when I is equal to 1, this gets executed one number of times, this gets executed 1, and this gets executed one number of times. Sorry, n by 2 times into 1. When we have I is equal to 2, this is 2, this get executed 4 number of times, and this iteration occurs 4 into n by 2 number of times. Similarly, for we have I equal to 3, this is 9, this is 3, this will get executed 9 number of times, and this gets executed 9 into n by 2. So when we have to find out that when for I equal to 3, how many times this loop gets executed, we add these values. Okay, in the previous slide we saw that for calculating the time complexity for I equal to n, we need to add till if we take out n by 2 common, so we see that this is a sum of n natural numbers, square of unnatural numbers, which is equivalent to so after we do this, we can see that after we do this calculation, we get to know that time complexity is n to the power 4. This is called polynomial time complexity. In the previous session, we got log 2n as the time complexity. This is logarithmic time complexity. Anything n square, n cube, n to the power 5, this comes under polynomial time complexity. Okay, now this was all about iterations. Now let's try to see for recursive.